Greetings from the beautiful Norwegian Bliss and for our online version of our noise evaluation session. Okay, so to get started, let's talk about what we're going to be talking about in the next few videos is assessing and measuring noise levels and the frequencies. That's going to be important to us. We'll talk about that in a second. Using sound level meters, dosimeters, octave band analyzers, and various tools that industrial hygienists and noise specialists use to measure the amount of noise, the amount of sound that's present, documenting noise exposures using dosimeters, and using those to determine whether or not a noise exposure could be damaging or exceeds OSHA's permissible exposure limits. And then finally, we're going to be talking about various devices, headphones, various other kinds of devices to attenuate sound to protect hearing, hearing protective devices, engineering solutions to reducing noise, and so on and so forth. So we're going to be covering a lot of territory when we talk about noise, exposure to noise. So first part of this is going to be sound basics, the engineering basically of sound. Okay, so starters, sound is the movement of pressure, compression, and rarefication of molecules of a fluid moving through air. So typically the fluid we're concerned about is air, of course, because that's most workplace environments, most normal environments we work in, but it also can be water, for instance. You can have a pressure wave moving through water. And you know, water, in fact, can carry sound long distances. So basically, we're looking at a pressure wave, compressed molecules of sections of molecules of air, then rarer sections, compressed, rarer, and so on and so forth. And the how close these bands are together is the frequency of this. So this can be described as a pressure wave. So here's a kind of a sine wave that we see here, and this is an area where the pressure is a little bit higher, pressure is lower, higher, lower, higher, and how many of these cycles that we have per second are called hertz. Okay, so hertz and cycles per second are equivalent, and the air is uniquely designed to sense these pressure waves, this difference in pressure as sound moves through air. Oops, let me get back a second here. Okay, so here are sound basics. Okay, so this it's basically a sinusoidal waveform. Okay, and you can see here time is on the bottom, and the amplitude or the pressure is on the top. Lowest pressure, highest pressure. Okay, so how do we measure pressure? Okay, well, okay, so to measure pressure, we're going to define it as the difference between the crest and the trough of the wave. That's going to be our amplitude, or the maximum amount of pressure difference between the compressed air and the rarefied air. That's going to be a measure of the energy that's in the sound. And the energy that's in the sound is basically the intensity or the loudness of the sound. Okay, so how do we define that? Well, most of the time we're going to be talking about a measurement called decibels. Okay, decibels is a logarithmic scale. Our ears are sensitive to a wide range of sounds, from very tiny changes in pressure to very large changes in pressure. The weakest sound that average person can hear is 20 micropascals. Okay, that's a tiny amount of pressure. Okay, this level, this minimum threshold of hearing is called, we refer to as a reference level. Now, to put that into perspective of how wide this scale is, the threshold of pain, in other words, the sound being so loud that it's painful, and you've experienced this on occasion, is 10 million times greater than the minimum sound pressure level that we're sensitive to in terms of the amount of energy, in terms of pascals. Okay, so that's an enormous difference in the amount of energy that's in sound waves that we're sensitive to. So what is noise? What is the difference between noise and sound? Sound is any thing that we can hear, any change in pressure in the air that we interpret as hearing. Noise is sound that has no useful information, is unpleasant or is unwanted. And in some cases, we also talk about certain kinds of white noise and pink noise that varies randomly in time. And we'll deal with that a little bit later on when we talk about noise sources and so on and so forth. Okay, so why are we concerned about this? Well, sound, whether we want it or not, in other words, if we're listening to music through our earbuds or if it's unwanted sound, which is noise, either one of those can be damaging to our hearing. Okay, if you're at a rock concert or something like that, you're exposed to high levels of noise. You have your earbuds on. In fact, when earbuds first started getting popular, there was a lot of controversy about them because the amount of sound level that you get out of them was virtually uncontrolled. And so you could be exposed to a lot of noise from earbuds. Now, most devices are self-limiting. In other words, there are safety features built into the device, like your iPhone or your iPad or something like that, that limit the amount of magnitude of the sound that'll put out to the earbuds and regulate it as the music gets louder and softer, and regulate it to protect your ears to some degree. There may be ways to turn that off. There may not be ways to turn that off. But things are a little bit better regulated now. If you have your own personal devices, you should check to see if they will protect your hearing or if the features that are installed to protect your hearing are actually there and actually are working correctly, okay, and set up and working correctly. You might want to consider, for instance, what kind of occupations are routinely exposed to large noise levels. Okay, so for instance, go online, Google, and check to see if your favorite musician, for instance, over the years of playing with bands or performing, if he's developed a certain amount of hearing loss. And I would be willing to bet that a lot of your favorite musicians, in fact, have issues with hearing loss. What other kind of occupations? Race drivers and so on and so forth. We're going to be dealing with probably most of the time with more mundane occupations, but certainly those are two that certainly you would think are exposed to loud noises for long periods of time. Okay, so there is a combination of exposure, the amount of intensity of the sound, the loudness of the sound, and the length of exposure. And those two work together to increase the amount of damage that might be done to your ears and to your hearing over the longer term. Okay. Loud noise over a short period of time, typically you will recover from. But if you're exposed repeatedly over longer periods of time to that same sound, then that damage becomes permanent over time. Okay, next time you go to a rock concert and you drive home or you're listening to your earbuds on a train on the way home or something like that, after a loud rock concert, try this experiment. When you get home, okay, and you're about to put your device down or you arrive home in your car, set your radio or device to a loudness that feels comfortable for you to listen to. And then in the morning, after your ears have had a period of time where they could recover, put that instrument on again or when you start that car up, and don't be surprised if the sound intensity sounds ridiculously loud to you because your ears had lost sensitivity, had experienced short-term damage that you recovered from over the a few hours from the night before. So give that experiment a try and see if, in fact, you can detect a certain amount of hearing loss that was temporary. Okay, so the ear responds differently to various frequencies of sound. Okay, now not all frequencies are the same. Low sounds, mid-range sounds, high sounds. Your ear has different sensitivities to these different frequencies. We're most sensitive here's a illustration of different methods of measuring the amount of level of sound that we're hearing. This Z line that you see here, this blue line that's going straight across here, that's a measurement of the sound levels that's averaged so that all the different frequencies are equally weighted. So if we're reading an instrument that is just averaging all the different sound levels, all the different frequencies and so on and so forth together, then it would use that line. In other words, it would weight very low frequency sounds exactly the same that it weighted higher frequency sounds. Well, in fact, our ear doesn't hear that way. Our ear is, in fact, more sensitive to mid-range sounds from 1,000 hertz up to about 8,000 hertz. In other words, frequency 1,000 cycles per second to 8,000 cycles per second, or hertz, as it would be termed. Okay, and our hearing is particularly sensitive in that range. And our ears are not as sensitive to very low frequencies, 31 cycles per second, for instance, right? Still within the range that we can hear, but at very low frequencies, very low bass sound, for instance. Okay, so uh, 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 those levels of sound, same amount of energy at a low frequency, uh, 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 it doesn't affect our ears as much as the same amount of energy at a mid frequency because we're most sensitive here. So, in fact, it doesn't do as much damage to our ears. So, in order to understand and measure the amount of sound that we're exposed to that is actually affecting us, we use various different weighting networks or bit weighting bands. Okay, and the one that we see most frequently is the C band and the A band. If you notice this, the C band is very close to just measuring all frequencies at the same intensity, weighting all the different frequencies of sound at the same levels. While the A band, if we look down here, the A band is the one that reflects our hearing, the way our ears work the most. So the A band is frequently used to measure, the A band on an instrument is frequently used to measure the actual noise exposure that a worker or that humans would be exposed to. So notice how it discounts or lowers the weighting for low frequencies and very high frequencies, and overweights the middle range frequencies, 1,000 hertz to 8,000 hertz. That's where our ears are most sensitive, and where the energy from the noise that comes from those frequencies is going to affect our ears the most. So it's not surprising now that those are the frequencies in which we're best adapted to hear, because those are the same frequencies that human speech typically ranges at, those frequencies. So we are basically have evolved to be most sensitive in the areas at frequencies that would be most important to us. For instance, look out for that saber-toothed tiger or something like that. Guys that didn't have sensitive hearing in that range, right? They got eaten by saber-toothed tigers, basically. Okay, so there's the weighting. There's an example of the weighting and so on and so forth that we would see. So how does the ear work? Well, those sound pressure waves enter the ear. The air funnels that sound into the ear canal, and at the end of the ear canal we have the eardrum. The eardrum is connected to a series of three bones that carry sound vibrations from the ear bone to the cochlea. The cochlea is a kind of a circular kind of shell device that's filled with fluid, and in there are also these tiny cells that have tiny little hairs. Those hairs are connected to nerves, the cochlear nerve, and they activate the cochlear nerve. And those little cells actually, as they vibrate, they activate the nerve and they carry that sound information to your ear. And these are very tiny little bones and very sensitive tiny cells and hairs and so on and so forth, cilia, that are within the cochlea. And over time, these cells do not recover. So, for instance, if you drink some alcohol, you might do a little bit of liver damage or kidney damage, but your body recovers from that, assuming that the exposure to that material is not too great. Unlike that, these cells that are in your ear do not recover. They don't grow back again. If they're damaged, they don't grow. And in fact, interestingly enough, the hairs, the cells with the hairs that are closest to the vibrations, where the vibrations enter the cochlea, are the ones associated with the higher frequencies. So it's not surprising that as you age, that exposure to noise over time affects the higher frequencies, because it damages the hairs that are closest to the source of the sound pressure that's being carried through your ear, right? So you may notice that as people get older, that they're less, their hearing is affected, particularly if they're exposed to large amounts of noise over time, and they're particularly affected in higher frequencies. When we do the lab next week, you'll notice that we're going to be doing some demonstrations, and I'm attaching some YouTube videos that you can use to check your own hearing for different frequencies. But you'll find that people, as they get older, they're less sensitive to higher frequencies of sound. One of the apps that I asked you to consider downloading is called the Mosquito ringtone, and it got a little bit of reputation a while ago because it makes a sound kind of like a mosquito, a high pitched noise. And when cell phones were being banned in high schools, students were known to install this ringtone because the frequency was so high that people under 24 could hear it. People over 24, because they had already started to lose some high frequency hearing, people over 24 typically couldn't hear it. So they could have a ringtone that their teachers or instructors who were older than them couldn't hear. So it might be a good demonstration. There's a couple of YouTube videos where you can actually test your sensitivity to different frequencies, to the intensity of different frequencies of sound. These, of course, are not real clinical tests, so I wouldn't get too crazy if your hearing is not too great on these things, because they are kind of crude tests, and they may not be as accurate as it's certainly not as accurate as a test that a professional audiologist would use. But it's pretty interesting, and you'll see that as you get older, that you will lose some of that hearing. Okay, so we're going to move on from there to our next section, which is going to be measuring sound levels and worker exposure in our next video.